So really quickly before we look at the later ones, I just want to remind you of what a transversal is. So super important. We're going to do a lot with this. So transversal, it's a line that intersects two or more other lines. So I went ahead and highlighted our transversal. We also talked about notation being super important. So if it's a line, we call this JK to signal that it's a line. We got to make sure we have our arrows above it. So that is our transversal. It's talking about which ones are parallel. We know that those arrows right there mean that they're parallel to each other. So these would be my parallel lines. So I would need to say that LM is going to be parallel to NP. So we can say LM is parallel to NP. So there's our symbol for parallel that we could use. All right, so then if we trace angle X onto patty paper, we can move it up. I'm going to go ahead and trace all of them, and then we can kind of see what those angle pair relationships are that we're going to discuss that corresponding in the next one. So if I then quickly do that. So again, on yours, it only said B and X. So if I have B, and I'm going to mark D, I'm going to go ahead and mark A and C. So if I slide those down, if I translate, it doesn't change the size of anything. So we're going to see that B would now turn into where X is, D is going to turn in where Z is, A is going to turn in where W is, and C is going to turn into Y. So that's what it goes on to talk about in C. That's what corresponding angles are. Angle X and angle B. They're in the same position. We just literally are translating them down to the other part. So if we want to name all the other pairs, so you're going to look at your paper while I'm naming these, but we already have B and X. Those are in the top right. We would also have angle D and angle Z. So angle D and angle Z are corresponding. We would also have angle C and angle Y are corresponding. And then our last set, besides B and X, we would have angle A and angle W. So those are going to be our sets of corresponding angles. Okay, so then it gives you, if B is 60, you can fill in some other things. So we can use vertical angles, what we know is true about them. That's super important. We can figure out supplementary, what we know about them, and any corresponding. So we should be able to fill in with those values what that is going to look like. So you can write out what each of them are going to be. Right, so I'm going to fast forward a little bit to these questions. So again, if I want to fill in X and Y, it talks about find the measure of them if you're able to, and state the relationship. If you do find the angle measure, state the relationship. So if this one here is 135, if it's really just a translation, so this right here is going to be 135, and the reason that is because they are going to be corresponding angles. So corresponding angles is why we know that. And then if I want to go from X to Y, I know that this is also going to be 135 degrees because I know that those are vertical angles. So again, vertical angle is going to be super important. It's going to be very important throughout the year. So then if I look at this one, 135 is here. That X, that's not just a translation. We can see that that angle is very different than what this is. So I actually can't find that X. But I can find Y. If I put those two angles together, it does give me that straight line there. So I know that those are supplementary. So I can say Y is going to be equal to 45 degrees. I can do 180 minus 135 and get 45. And the reason I know that that is the case is because it's a straight angle or linear pairs, and they are supplementary, but I'm going to use the official term. So linear pairs. Okay, so it's a pair of angles that are going to give us a line, hence the reason linear pairs. So looking at this, again, if I were to take patty paper and trace, I would see that that's definitely going to be the exact same thing. So this is 135, and again, I know that that is true by corresponding angles. So I'm going to abbreviate it a little bit. And then if I look at the X and the Y, their relationship is also that straight angle linear pair relationship. So this is going to be 45 degrees. I wrote linear pairs over here, but straight angle is another way that we can write it. That's what we'll see in our book quite a bit. So if I put two angles together and it gives us a straight line, we know that that has to add up to 180. So Frank's question, does corresponding angles always have equal measures? If I look, technically these are corresponding, right? They're in the same spot, but we can see that those definitely aren't the same. Even this one, I guess I can find 45. I skipped that one, 45, and we know that those are linear pairs or straight angles. But if I translate down, the corresponding would be here, but that's not the same measure of those, so I actually can't find Y there. So things that I have corresponding that are the same, I have these two diagrams, and then things that are not the same for corresponding, I have two. So looking at the difference there, those things are different, and we can't always say that corresponding angles have equal measure. They're only going to be equal when we have what kind of lines. So look at what kind of lines we have over here versus what kind of lines we have over here, and that's what we can write for this particular answer right here. So I'll let you go ahead and figure that out and write that in. So then the last important thing, talking about conjecture, conjectures are often written in the form if and then. So we have an if-then statement. It's also called a conditional statement. So make a conjecture about corresponding angles by completing the statement. If this, then corresponding angles have equal measure. So we need to fill in if, and based off of what we determine about the lines up here, we're going to be able to say corresponding are going to have equal measure. So I'll go ahead and give it to you. Hopefully you figured out above what's going on, but if we have parallel lines cut by a transversal, then corresponding angles are congruent. So that's going to be our conjecture. If we have parallel lines, or if we have parallel lines that are cut by a transversal, then corresponding angles are congruent, or corresponding angles have equal measure, however you want to write it there. So if I go back up here, hopefully that makes sense. These arrows definitely mean that they're parallel, so that's why those corresponding angles x and 135 are the same, 135 and x. But if I look at these two lines here are definitely not parallel. So this being my transversal is here, and my transversals here, and my transversals there and there. All the highlights are transversals, so those are parallel, those are corresponding angles are congruent here, corresponding angles are congruent there. So only if we have parallel lines. So just looking at a couple of these really quickly, I can kind of fill in some things, or try to fill in some things. So if this is 115, I have a straight angle there, so that is 65. I can then go corresponding. So if I were to translate this vertex over to here, the 65 would go here, so those are corresponding. But then these are also parallel, so I can actually translate this up, and these would also be corresponding, so I can say that x is 65 degrees there. So if I look at 53, I can fill in some things. So corresponding, these are parallel, so I can translate this vertex over, and that 53 would slide into that spot. So one other thing, I guess I didn't show this earlier, but if it helps, you could put a box around them. So we can see the bottom left, those are the same thing. But I can't go from here to here because these lines aren't parallel, so I'm actually stuck. I can't figure out what x is going to be there. I can only go from this vertex to this vertex as far as the translation goes. So that's all I could do there. I mean, I could figure out straight angle. I could do that this is 127 and 127 and vertical 53, but I wouldn't be able to find that x. So then the last one here, really quickly, we got a couple things. So we got two sets of parallel lines. So vertical angles, I could move 3x plus 10 in. If I wanted to, I could also move vertical angles. I could move 4x minus 25 in there. But then I have some corresponding, right? So parallel lines in this transversal, I could translate up. So then I have a 3x plus 10 there. And we can see this would also, so this angle here where this is, would correspond with this one. So I could say that those are going to be equal. So as I move things around with vertical angles and all that stuff, I could actually say that those are equal. So I could say 3x plus 10 is equal to 4x minus 25. So a couple things. This and this, the two highlighted angles, are not vertical angles. Okay, those are not vertical angles. Vertical angles are the 3x plus 10 and this 3x plus 10. So the green are vertical angles, but what I just had as the yellow are not. So then it's just a basic algebra 1 from there, minus 3x on both sides. And then this is gone. 10 is equal to x minus 25 plus 25 plus 25. X is equal to 35 degrees. So then we would be able to solve for x there. Okay, so a couple other important things, super important. Make sure you read math notes, how we label things. Again, labeling or symbols are going to be super, super important in geometry. So hopefully this helped a little bit. And make sure we finish 2-1-2 homework for tomorrow.